Okay, part 3. You may want to have your spiral out for this one so that you can take a few notes in your spiral because we're going to do some things off to the side that might be helpful for you, okay? We're going to start by just kind of relating our special right triangles to this trig table, which this is nothing new. Except for the 0 and 90, which we'll talk about in just a second. But we're going to relate this. We're going to look at it in terms of our unit circle, and then we're going to talk about tangent because tangent is going to require a little work. The unit circle is fabulous. It's really quite magical the way that it works. Notice that what I was doing when I was going left and up, or right and up, or left and down, whatever, that was right and up. I was using the adjacent and the opposite, and my hypotenuse was 1. So when I do sine of 30, 1/2 over 1. Cosine of 30, square root of 3 over 2 over 1. If I were to do, flipping it, cosine of, or sine of 60, square root 3 over 2, sine of 60. And if I were to do cosine of 60, 1/2 over 1, or just 1/2. Same for the 45, 45, 90. So cosine is going to be, or sine rather, is going to be square root 2 over 2 over 1. Cosine is going to be square root 2 over 2 over 1. Okay? Now, here's the thing about tangent. And actually, real quick, before we do that, looky. Let's do 30 first. Sine is 1/2, cosine is square root 3 over 2. See that? See that? Same two numbers, in a different order. Cosine, sine. For 45, we have square root 2 over 2, square root 2 over 2. For 60, we have square root 3 over 2, 1/2. Now, I could keep going around the circle, but let's focus on this first quadrant first because everything's positive there. We like it when everything's positive. Now, what ends up happening, and we are going to write that on here, every single time in your unit circle, here's the wonderful thing. The x-coordinate ends up being cosine of theta. Whoops, that's supposed to be a comma, not a parenthesis. The y-coordinate ends up being sine of theta. Darn it, I was trying to keep it so neat, and then I made that little boo-boo. Cosine of theta ends up being here. Sine of theta ends up being here. To remember, you know what I do? I go, x comes before y, c comes before s. So cosine is your first one, sine is your second one. It's not a coincidence. It's really not magical. Look at what we did to find our cosine. We did adjacent over 1. Look at what we did to find our x-coordinate. We went to the right. Okay? Now, let's talk tangent. I'm trying to decide what to do next. Let's talk tangent. So tangent, remember, is defined as opposite over adjacent. I'm going to give you a different definition. Sine over cosine. Let me show you why that works. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And we use our complex fraction there. I know some of you skipped this step, but I want to make sure we all understand. When I keep it, change it, flip it, boom. Right? So here's what that means for me. If tangent is sine over theta, and cosine is your x, sine is your y, that means that tangent is y over x. So look at our tangent. Let's do for 30. Ready? If I do, y over x, sine over cosine. So if I do 1/2 over square root 3 over 2, let's go ahead and keep it, change it, flip it. I get 1 over the square root of 3, rationalizing that denominator, I get square root 3 over 3. Okay, let's look at 45. If I do square root 2 over 2 divided by square root 2 over 2, guys, I'm going to get 1 because they're the same. It's like 10 over 10, negative 45 over negative 45. That's going to be 1. If I do for the 60, if I do sine over cosine, remember this is just a big division problem, keep it, change it, flip it, I get square root 3. So that's where my tangent's coming from, okay? Now, here, cosine of 90 is 1. I'm sorry, cosine of 0 is 1. Sine of 0 is 0. Cosine of 90 is 0. Sine of 90 is 1. Cosine of 180 is negative 1. Sine of 180 is 0. Oh, we never labeled this one. I went to the left and right 0 and down 1. Cosine of 270 is 0. Sine is negative 1. You can always do that in your calculator if you don't believe me. I'm looking for my calculator. I seem to have misplaced it, so I'm not going to use my calculator, but punch it into your calculator and you'll see. Make sure you're in degrees, okay? So when I look here, we set at 0, it's 1 comma 0. When I do sine divided by cosine, I get 0. Look what happens at 90. Tangent, 1 divided by 0, undefined. There are going to be some values for tangent and for your other reciprocal functions as well, your secant, cosecant, and cotangent, that are undefined. They're going to happen at those quadrantal angles because of the 0. Okay? All right. So I know that was quite a bit going on there. Let's summarize a little bit, and then we're going to talk about our second, third, and fourth quadrants in a different video. Okay, so we're going to summarize just a little bit. So first of all, for our 30-degree angles, or actually right here first. So our cosine is x, our sine is y, our tangent is y over x, sine over cosine. In fact, if we want to write that there, that might be a good idea. Okay, for our 30-degree angle, we can do it from there, but most of us understand this a lot better. For our 30-degree reference angle, our sine is opposite over hypotenuse, so our sine is 1/2. Our cosine is square root 3 over 2, and then our tangent, I did that right here, is square root 3 over 3. Okay, for our 45 is beautiful because I don't have to think about whether it's x or y. They're both square root 2 over 2. And then when I divide square root 2 over 2 divided by square root 2 over 2, it's 1. And then for our 60, our cosine is, our sine is square root 3 over 2. Our cosine is 1/2. And then our tangent, we did right here, square root 3. going to talk about this and about second, third, and fourth quadrants in the next video.